So let's take a look at shatter. Let's blow up a layer. We've got our shatter.aep project open here. That's the 5-shatter project. And we've got comp1, the shatter intro open, and we've got our layer here. There's actually 2 layers down here, but we'll activate the other one a little bit later. Let's select our layer 1 and apply effect, simulation, shatter. Now I've created a preset workspace up here called effect layout, and I'm going to choose that, and that's going to rearrange our windows a little bit so that we can get a better view while we're working. Now shatter is kind of an unusual plugin. If you look at the screen here, you'll see things have changed dramatically. Our image has completely gone away and has been replaced by this sort of brick-shaped grid tile pattern, and what kind of looks like a pie chart. This is a working view. This is basically a setup view for you to adjust the shatter map, which is what the bricks are here, and where you can adjust the area of explosion, which is what the pie chart represents here. A quick tap on the space bar might clarify things a little bit. As we tap on the space bar, you'll see our brick shapes have blown out of the screen, and they have blown out of the screen from our pie chart area. So from this, you might deduce that shatter breaks an image up into a pattern that's shaped like bricks and blows it up within the context of this blue pie chart. To that degree, you'd be pretty much correct. But that's only the very, very most basic way of looking at shatter. The very first available pop-up here allows us to see things somewhat more clearly. I'm going to scroll back the timeline so a few more pieces are on screen. And if we look at the pop-up here, you'll see that the default setting wireframe plus forces is giving us a wireframe view of our pieces and a representation of the force that's blowing the pieces out. That's what this means. This blue pie chart is the force sphere, and the wireframe of the brick shapes represents the geometry of the pieces that are being blown out. The other available choices in the pop-up are just a wireframe front view. You'll see the perspective change a little bit. The front view allows us to come back around to the front even if we've used our camera to adjust things off to the side. We'll talk about that a little bit later. Wireframe without the forces. Wireframe front view. This is the same as this one, only this one has the forces and this one doesn't. And rendered, which is, of course, the view that you want to choose when the time comes to actually render your masterpiece. If we hit the home key and jump back to frame 1 and hit the space bar again, you'll see at rendered, you'd get something looking a little more like what you would expect from a normal After Effects plugin, where the pieces of the layer are actually blown out into space. The view pop-up allows us to toggle between this rendered view and all of these working views, which are important to us at different times, as we'll see throughout this demonstration. I'm going to go back to wireframe plus forces because it's the most useful view to explain most of what's going on inside this filter. From a designer's point of view, one of the most important things you'll want to work with is the shape of your shatter because, of course, bricks are not going to be appropriate for everything. Bricks are the default. They're easy to see, but there's a whole bunch of other patterns available inside shatter. 20 of them are built in fact. Plus, you can create your own custom patterns, so essentially you have infinite patterns available to you. But some of the built-in ones are very fun, like puzzle pieces. Looks really, really interesting. Creates really great puzzle piece animations. And glass, also extremely useful. You'll use glass a lot, no doubt. Now we'll keep glass here. Let me jump back home again. We'll keep the glass pattern up because it's a very useful pattern for demonstrating some of the next things we'll talk about. Repetitions lets you adjust the scale of the map. Now you may go looking around for a scale function, but it's not in here. The function that controls the scale is repetitions. And it's called repetitions because all of the built-in shatter maps are actually tessellated patterns, meaning that they're designed to repeat. So when you crank up the repetitions, you are cranking up the repetition of the tessellated patterns, meaning that you're essentially generating repeating tiles of the pattern. And as we crank the repetitions up here on glass, that should be very, very clear exactly what's going on. So a higher repetition value scales down your shatter map. A smaller repetition value will scale it up. Useful thing to know. Direction also allows you to rotate the direction of the shatter map. Pretty obvious. The origin point allows you to drag the shatter map around on screen. So say you had a baseball that you wanted to come busting through the window up left, and you wanted the braking pattern to radiate from where the baseball hit, then you would probably want to move the center point of your glass map up to the point where you want the baseball to hit. So these kinds of controls let you fine-tune the breakage patterns inside Shatter. And while all of these controls have to do with adjusting the white lines that you see on screen, the extrusion depth control that you see here allows you to adjust the gray lines that you see on screen. They're very faint, that exist connected to the white lines. Shatter is not one of your run-of-the-mill layer exploding plugins that basically bust things up into flat polygons. Shatter actually creates extruded geometry, which actually allows Shatter to create big, thick, chunky pieces within the simulation. And the depth of these pieces really helps add realism to a Shatter explosion. In addition to that, you can see as we adjust the extrusion depth, the pieces kind of jump around on screen. That's because the simulation itself is having to be recalculated to take into account the extrusion depth. Shatter actually is a physics-based system, so the mass of pieces matters. A big, thick, chunky piece will have more mass than a thin piece will, and so the physics that interact with that piece will be changed by adjusting the extrusion depth. Generally speaking, I wouldn't recommend that you animate this particular value. But if we jump over to the rendered view again, you can see pretty clearly what's going on here. A higher extrusion depth gives you big, fat, chunky pieces out of your layer. So that's how to control the shapes inside Shatter. Let me go back to wireframe plus forces. We'll take our extrusion depth down to something like 0.1, which would be much more manageable. Well, also, one last thing to mention about extrusion depth. There are times when a Shatter map will get very, very complicated with lots and lots of pieces on screen. Well, an extrusion depth takes a triangle, which would be one polygon, and turns it into, let's find another triangle on here, it turns it into 1, 2, 3, 4, 5 polygons, because you've got a polygon on the front of a triangle that's got extrusion, a polygon on the back, and a polygon for each side. So extrusion actually contributes to a high polygon count within Shatter. Turn extrusion depth down to 0, and now it's only got to keep track of one polygon on screen for each Shatter piece, so your memory requirements will go down. If you're starting to work with a really, really detailed Shatter map like sand or something like that, you might want to turn your extrusion depth down so that Shatter doesn't have to consider so many polygons on screen. It's nowhere near a problem in this situation because we don't have that many polys up there. So let's change this back to 0.1 again. And let me hit the Home key and switch our pattern back to bricks. In fact, let me just reset our filter here to bring ourselves back to the defaults. And now let's talk about the pie chart. Let's talk about the force sphere, the thing that actually creates the explosion. To do that, let me twirl down our shape controls and actually go down to our camera control here. Yes, there is a camera inside the Shatter filter because Shatter is a fully 3D system. It creates 3D particles and it puts them in 3D space. You can even, if under the camera system pop-up you choose Comp Camera, you can even use After Effects built-in camera to position the Shatter effect, but we're going to talk about that much, much later in the program. For right now, let's just use the basic camera position controls, and if we twirl those open, we can rotate the camera around the X-axis, that's the horizontal axis, rotate it around the Y-axis, that's up and down, or around the Z-axis. And Z actually runs sort of perpendicular to your computer screen, so that the Z-axis would be the depth of the scene. Rotating around X would tilt the scene this way, rotate it to a negative amount. Rotating it around Y twists it around this way, and there we can clearly reveal that beach ball shape I was talking about. The Shatter sphere, the force sphere, is kind of a beach ball shape here. And let's also adjust Z position so that we can move our scene away from us in 3D space. We'll come back to adjust these from time to time to basically just get a better view of exactly what we're doing. In fact, if I rotate around on edge, you'll see that our Shatter scene starts out with our Shatter sphere intersecting the layer. This is incredibly important. Shatter pieces are given permission to explode when the pieces come in contact with the force sphere. Only pieces inside the sphere blow up, and pieces outside the sphere do not blow up. It's very, very easy to see this in action by just hitting the space bar, and you'll see that this circular area is intersecting the sphere, and therefore the pieces inside are given permission to blow up, and then everything about that is driven from the other controls inside the application, the physics, and so on. Now, controlling the force sphere is extremely important. You do that in the force controls. Twirl that open. Now, the force controls only give us 4 things to work on. That's all we need. Basically, they allow us to adjust the position of the force on screen, the depth of the force on screen, the radius, which is the size of the force sphere, and the strength of the explosion. Now, adjusting the position is kind of difficult to do from an extreme camera angle like this, so this is an excellent opportunity to use one of our other working views. Wireframe plus forces allows us to see the wireframe of our layer plus the force sphere, and it allows us to see that in the perspective set by the camera controls. But if instead we choose wireframe front view plus forces, it'll temporarily ignore the camera controls and bring us around to our front view where we could now freely reposition our scene. Now, we don't have our shatter filter highlighted, so none of our shatter controls are showing up in the window. But if I highlight shatter and now click and drag in the center, I'm going to actually move around my pattern, which is okay. That's no big deal. So let me move that over here. And then the second control under that for me to click and drag is our force sphere, as I click and drag it around. Of course, I could also just click on the position plus sign over here and set it anywhere I like on screen, and then click and drag from that if you don't want to actually reposition your tiles on screen. But put the force sphere anywhere that you want it on screen. Let's blow the upper left-hand corner out of the screen, for example. Set it back to wireframe plus forces. Now you hit the space bar and you'll see we've pretty accurately carved a chunk out of the upper left-hand corner of the screen. Now depth adjusts the Z position of the force sphere in space. A positive depth value will move the force sphere behind the layer, causing the pieces to blow forward. A negative depth value, let's just add a minus sign to the front of our depth, will blow the pieces back into the screen. Okay. And of course, you can just click and drag this interactively and see how it interacts with the pieces. Now, the radius of the sphere basically controls the size of the sphere. Crank that radius way up. Once it encompasses all the pieces, the radius value isn't going to have any further effect. So, boom, all the pieces get blown up. And as soon as you crank the radius value up high enough to encompass them, any higher value is not going to have any subsequent effect. A very small radius value, of course, could get so small that it doesn't even intersect the layer. If the force sphere is not intersecting the layer, no matter how hard you hit the space bar, you're not going to get an explosion at all. Now, this is a very, very important thing to know, because the radius and the depth are the key to controlling exactly when your shatter occurs. I'm going to adjust my camera rotation so it's not quite so extreme, now that we know that our force sphere is slightly behind our layer, and that if we hit the space bar we get no explosion. We're at an excellent starting point to control the timing of this explosion. If we do not want an explosion to occur until 1 second into the animation, then we either need to animate the depth or the radius of our force at 1 second in order to cause the force sphere to intersect the layer. For example, if we set a keyframe for depth at this point, move a couple of frames forward, and adjust our depth down to 0, then over those couple of frames, the sphere is now going to intersect the layer, and exactly 1 second into the animation, boom, the pieces in that corner are going to blow out. And we've adjusted the timing accordingly. Boom. Perfect. Now we can do exactly the same thing by animating the radius. Let me hit the U key to find our depth keyframes and delete those. And instead of handling depth, let's work on the radius values. So once again, let's jump out to about 1 second and set a keyframe for radius. And now we'll move forward a couple of frames. Let me hit the U key so we can reveal our radius settings down on the timeline. And let's adjust our radius up so that some portion of our larger force sphere now intersects the layer. We'll go back home again, hit the space bar, and you'll see that at 1 second, once again, the sphere gets bigger this time, carving a slightly larger chunk out of our layer, and we have precisely controlled the timing of our shatter effect. Now, in these last two examples, we did a very, very abrupt change, but there's nothing in the world that says you actually have to do that. We could create a much slower expansion effect, and in fact, if we go to this second value and really crank the radius up so that it encompasses the entire layer, you'll see one of the real advantages to animating the force sphere's radius, and that is you can create a really cool shockwave type animation. This is going to be unlike anything you'll see in any other After Effects plugin that does these sorts of shatter effects. A quick RAM preview allows you to see a very interesting shockwave style effect on that layer. Now we'll be doing several more of these as we go along. What's important about what I just said is that the way to control the timing of a shatter animation is to animate either the depth or the radius so that you control when the force sphere intersects the pieces on screen. It's important also to understand that the strength of the explosion has nothing to do with this equation. If I jump back to frame 0, a lot of times people will crank up the radius and think, it's a pretty good assumption to make, that if the strength starts out as 0, there shouldn't be any explosion. But that's not how shatter works. Even with the strength value of 0, if the pieces are intersecting the force sphere, it means they've been given permission to move. And even if there's no explosion value, even if there's no force in the force sphere, by being given permission to move, it means that shatter's other physics, gravity, for example, will take over, and a quick tap on the space bar will show us that all the pieces in a big chunk will basically fall out of the screen. In fact, that's a pretty funny animation because there's some tiny little slivers of pieces along the edge here that, due to the default viscosity settings, are falling slower than the rest of the pieces in physics. So we're leaving this interesting little dotted line behind. You get a lot of funny artifacts like that when you work in a true physics-based environment. We'll talk more about this physics, about the mass of the pieces, in just a couple of minutes. So once again, if we want to control the timing of our explosion, we don't want to worry about strength. We only want to concern ourselves with radius and depth. Let me adjust my strength back up to 5 and click OK. In fact, let me reset our effect once again. So now we're looking at things straight on. We also know that our default settings have us with a little bit of an intersection, and that's just fine. Let's animate a couple of these settings. I'm going to animate my radius up over time. Let me start with a radius value of 0. And over a second or so, I'm going to crank up my radius large enough to cover all of our pieces. So we get a nice shockwave animation. That's good. I'm going to adjust my shape size to something a little different. I'm going to pick a rhombi and adjust the repetition so we have a lot more pieces to work with. Close that down again and see how that looks. That's pretty cool. Now, just to simulate slightly more realistic physics here, while I'm animating the radius, I'm also going to animate the strength so that the strength gets a little weaker as the shockwave gets bigger. So as the shockwave expands, essentially the effect that it has on the pieces gets diminished. That'll result in a more realistic explosion. Here we go. And of course, for ultimate realism, we have not only given you a cool force sphere with all of these controls, we've given you 2 of them. So if you wanted to, you could actually combine forces. There's a lot of reasons to do this, and we'll go into a few of those as we go along through this demonstration. But in this case, I'm just going to show you that setting a keyframe for radius on the second force sphere and animating that up over time to a nice high value will add that explosion to our first explosion. And now, just for laughs, let's set our view to rendered and see what this looks like when we generate a quick RAM preview. You'll see we get our first explosion blowing out and then a second shockwave buffeting the pieces. Really adds just a little extra touch of randomness that creates a little more realism in the scene. Now there are, of course, some other cool things that you can do with forces. Let me hit the U key and get rid of all of the keyframes that we've created so far. And then I will just hit the reset button on our shatter filter to reset everything back to its defaults once again. I'll shift page down a couple times so that we can see our pieces fly out. And I'm going to adjust the radius of our main force down until we've just knocked a couple of pieces off screen. That's all we need. I'm also going to change our shape again, back from bricks to something like rhombi. That's a nice handy one to use for this kind of thing. Crank our repetitions up so we have a lot of little ones on screen. Here we go. Now I want to show you that not only can you animate the radius or the depth, but you can also animate the position of a layer. So if I jump to our beginning here and set a keyframe for position and jump, say, 10 frames in, by hitting Shift page down, I can now move the position point here. Let me once again click here and click somewhere else up here. We're going to need to highlight our shatter clip again that got deselected and hit Shift page down. and move over here, shift page down, move down here, shift page down, move over here, shift page down, move up here, shift page down, go back in the center again, and then set a keyframe for radius, shift page down a couple of times, and grow the radius up. We should have a nice, interesting animation now. And just for laughs, let's turn on our background layer, our furry T3V, so that we're actually revealing that layer behind our foreground layer. We'll set our view to rendered and show you that by following these steps, you can actually create a great little transition that looks as if you're painting with an explosive brush. So if we generate a quick RAM preview of that, you'll see we have a really fun and interesting transition. Very organic. Kerchunk and boom. So, yet another cool thing you can do by just adjusting the forces in Shatter. Now once again, I'm going to hit the U key and delete those keyframes we just created. I know it was a cool animation, but I'm going to get rid of them anyway. And we'll turn off our furry layer again, reset our Shatter. And I want to talk a little bit more about the physics inside Shatter. It'll help to use a Shatter map that actually isn't a whole bunch of particles of the same size. So if we pick another pattern, say the stars and triangles down here near the bottom of the list, that gives us a nice mix of fairly large particles and fairly small particles. We'll keep those default repetition settings for now, because that's a pretty good size. Also, I'm going to adjust our camera position a little bit. I'm going to rotate our scene back in space, rotate it around Y, and set it further back in Z so that we can see some of what's going on a little bit more clearly. Let's open up our physics settings. Now, the rotation speed is the first control. I need to drag this open a little bit more so we can see the full names of most of our properties here. The rotation speed is the default rotation setting of the pieces as they tumble. If you're not getting enough tumble, you can adjust the rotation speed up, or if you don't want any tumble at all, you can crank that down to 0. Tumble axis is by default set to free. If we set that to none, then all the pieces would forever remain perpendicular to the original plane that they started out. And the other choices in here allow you to constrain around particular axes, depending on how you want things to tumble. Free creates the most realistic shatters. Randomness has to do with a basic tenet of shatter physics. Let me jump back to 0 here. And if we rotate our camera controls around to the side a little bit more, so that our sphere is dead on here, shatter assumes that the force originates in the center of a sphere and moves straight outwards from that center point. So the pieces will be blown away from the center of the sphere, which is why when the sphere is slightly behind a layer, the pieces are blown forward, and when the shatter sphere is in front of the layer, the pieces would be blown backwards. But the randomness value adds a little bit of random direction to that. By default, it's set to 0.10, and that adds a little bit of turbulence. If it was set down to 0, then everything would be very, very precise. And you might get something that looks maybe a little more like fireworks, but in general, most explosions aren't quite this orderly. So some randomness is good. Set this value up to a value of 1, and the shatter pieces no longer pay any attention whatsoever to what the center of the explosion is, and simply choose a random value and get scattered every which way, which can also be very, very useful for very violent explosions. If you need something that isn't quite so controlled and quite so centered, then the randomness value set higher will give you better results. For our purposes, I'm going to keep that set down to 0.1, and let's talk about viscosity. Now, the viscosity of air is fairly low, but it's not as low as, say, a vacuum, outer space. In outer space, pieces get blown in a direction. They basically will fly in that direction forever until they whack into something or get affected by a planet's gravity or something like that. But in the air, there is some air resistance, so as a piece flies, the air slows it down and eventually gravity takes over and it tumbles to Earth. And that's what viscosity is controlling. A much higher viscosity might simulate an explosion in water. So if we cranked it up, you would see that the pieces would shatter just a little ways and then gravity would pull them down. Let me rotate our camera back around again and tilt it so that it's not quite so tilted back, and move a little closer to it so that you have a better feel for what's going on here. The higher viscosity, you just get a slight explosion, and then gravity takes over and pulls things off screen. Now, this illustrates, if you look closely, some of the physics going on inside of shatter related to mass. The larger pieces, the stars, if you watch them relative to the smaller pieces, you'll see that as far as viscosity is concerned, a small piece is more likely to be slowed down than a large piece. The large piece will get pulled faster off the screen than the small pieces. So the stars all fall completely out of screen long before the smaller pieces do. On the other hand, smaller pieces are liable to be blown farther by the force of an explosion than our larger pieces. If we went up to our force controls again and cranked up the strength to a much higher value, you would see that the smaller pieces get blown a lot further from the center of the explosion than do the stars. It's kind of confused on screen right now, but you should still be able to see that at the outer edges of our explosion, there are a lot more triangles than there are stars, and the stars tend to stay closer to the center of the explosion. So the bigger the piece, the less it's affected by the force strength, but the more it's affected by gravity once viscosity takes over. All of these things obviously work together, and in a subsequent lesson we'll show you some really cool things you can do with viscosity to create these kinds of matrix type effects. Now, mass variance has to do with just how much difference there is between the small pieces and the large pieces. The default values are pretty realistic, but if we crank up the mass variance, you'll see that that really increases the mass of the bigger pieces while decreasing the mass of the smaller ones. It adds a lot more variance between those extremes. So the higher the mass variance, the more the little pieces will be affected, and the less the big pieces will be affected. We still have our viscosity set pretty high, so everything still gets kind of frozen as if we're blowing up in water. So let me turn our viscosity values back down again to something more realistic, and you'll see that with a higher mass variance, the small pieces just get blown way the heck out, and the larger pieces just get slightly tipped out and then fall out of screen. So high mass variance values are interesting stylistically, but not necessarily for creating realistic style effects. Gravity should be pretty easy to understand. The amount of gravity is basically how much pull there is once viscosity has stopped the pieces. Of course, they all work together. A higher gravity value will make pieces fall out of the screen faster. The gravity direction allows you to choose the direction of gravity in X and Y, and the gravity inclination allows you to control the gravity value or direction in Z. So a positive gravity inclination, just as a positive depth value, will cause the gravity to fall away from the screen, and a negative gravity inclination would make the pieces basically fall into the screen. These are for very specialized uses, but this gives you real control over exactly how the gravity of the scene works. A lot of these things we're going to be using with other techniques as we're moving along. Just wanted to introduce these concepts, and that's just a quick introduction to the main things that you need to know to control Shatter's pieces and Shatter's physics, and very lightly show you how to control Shatter's camera. We're going to be using all of these things now in combination to create some much more interesting effects. So we're going to move on to our Shatter Gradients composition, which I've got opened up here. And in order to shatter with a gradient, we need to apply the shatter effect to our foreground layer here, our tint screen layer, which is this beautiful Steve Holmes composite of several other projects you may or may not have seen yet. And we're going to apply Effect Shatter, which happens to be up there because we've recently applied it. Your last applied effect always shows up here at the top. By now you should be familiar with what we're seeing here on the screen. I am going to go to my window workspace and choose Effect Layout so that we can zoom in to a more video-friendly resolution. So that we can see things in fine detail, I'm going to adjust my shape. I'm going to choose another pattern. Let's choose hexagons this time, which is a nice sort of general particle to work with, particularly at high repetition. So I'm going to crank our repetitions way up so that we have small particles to work with. And because I don't need to worry about a whole bunch of extra polygons on screen, once the particles get this small, I'm going to set our extrusion depth to 0. And that should speed things up quite a bit. All right, that's all we need for our shape controls. Now let's look a little bit at our gradient controls. Not much under here. There's something called Shatter Threshold, which is currently set to 0%. Gradient Layer, which is a pop-up that allows us to choose another layer in the composition. and invert gradient, which allows us to make things work backwards if we don't like the direction that things are going by default. So let's go through and talk about exactly how to work with gradients. We have several samples of gradients down here in the comp window. Let me double click on the first one. This is a linear ramp from black to white. Directly beneath that is a twirled ramp where we've got black at the top and the bottom, and then everything kind of twirls into a solid white galaxy spiral kind of thing. We've got some black to white fractal noise. We also have a black and white version of our T3V logo with an intermediate gray circle behind the 3. And we have a couple versions of bands, alternating bands of white and black, including some that have some noise thrown in there for good measure. Let's talk about exactly how a gradient is used to control things in After Effects. There's several filters like the gradient wipe filter, card dance, colorama, and several other filters that can actually use the pixels from another layer to control an effect. It's a very, very powerful way to work. But there's one important thing to know about it, and that is it can only see the pixels of a layer as those pixels are passed into the current composition. For example, if I double click on this layer, I can see that I have a ramp from black to white. These pixels can be used to control another layer effect in After Effects. But if I take this same layer and apply another ramp to it, render ramp, and now the ramp is going from top to bottom instead of left to right on the same layer, if I tried to use this gradient as a means of controlling another layer, it wouldn't work because these pixels only exist within this composition. They haven't been passed into this composition. All you have to do to see what pixels are available to you to control layers, double-click on that layer in the comp window. We can clearly see that the source layer for this layer, without any filters applied to it, is a gradient that moves from left to right. So it's very important. If we were to need these pixels, this vertical gradient, to control another layer in After Effects, we would have to pre-compose this effect first so that the effect wasn't applied within this composition. So that's one very important thing to know. Another thing to know is exactly how gradients are used to control other layers. Typically speaking, a gradient is used as a means of timing an event on another layer in After Effects. Let me select Layer 2 again by just tapping the 2 on the numeric keypad. And I'll go up and this time choose Effect, Adjust, Threshold. And you'll see how a threshold operation works. It takes a grayscale file and converts everything below a certain threshold value to absolute black and everything above a threshold value to absolute white. Well, this sort of operation tends to happen internal to other applications that use a gradient for control. For example, as you animate a threshold in Shatter from 0 to 100, it would be the equivalent of animating the threshold filter here from 255 down to 0. So that as this animates, white pixels represent an area of permission, an area in which something can explode. Let me show you an example of exactly how that works. Let's go back, turn off our ramp.psd, turn on our tint screen, and expand open our shatter window, because After Effects likes to snap to the size of the last filter, even if that filter is way too small to show you your current filter for some silly reason. So now, if we choose as our gradient layer the ramp that we just looked at, let that go, and now we hit the space bar, you might think that Shatter is somehow now broken because absolutely nothing seems to be happening. Go all the way out to a second and nothing has exploded on screen. But click on our Shatter threshold value and set it to 50%. Aha! And you'll see that everything inside of our force sphere has to be inside the force sphere, even with the gradient. Everything inside of our force sphere and to the right of that 50% threshold mark, according to the grayscale levels of the gradient, has been given permission to explode. So now all of the pieces on that side of the sphere are now off and running. So that's cool. You can create some interesting custom effects that way. But where this gets really fun is when you start animating the gradient. Let's jump back home again. Set our threshold back to 0%, set a keyframe, jump out to 1 second, and set our threshold value now up to 100, and take a look at what that looks like. See, within the confines of the circular sphere of force, we are now animating a linear wipe from right to left that looks like a shock wave, but a shock wave that only takes place inside our force sphere. So that's kind of fun. Of course, we could take our force sphere and make it large enough to encompass the entire layer, and that way we get something that looks much more like a traditional shock wave explosion, a little more realism. But as you can see, gradients allow you to fairly precisely control exactly the order in which polygons blow up on screen. Let's try a couple of different gradients now that we have set up our animated threshold value. We'll jump back home, and instead of our ramp, let's pick our gradient twirl and see what that looks like. Looks like a nice twirly pattern breaking out of the screen, and then the rest of the screen wipes off. That's pretty cool. You can choose the fractal noise, go back home, and you'll see we get a much more random effect, sort of a burn film burning through the image type effect. It's very cool, like that. Choose the T3V logo, and you'll see something interesting here. The white pixels that describe the T bust out first, then the circles for the 3 break out, and only at the very end do the rest of the particles get let go. So this shows you how different absolute levels and not a smooth gradient can give you some interesting animation. And let's try the bands. One's always fun. There's just no other shatter filter out there that can give you this kind of control over the order in which your particles blow up. That's pretty cool. And if we wanted to randomize that a little bit, we'd pick the noisier version of the bands. And you'll see we get a much more organic result with that gradient. So pretty cool. You've got some really great options here. What may not be obvious is you don't actually have to animate the gradient to control an interesting animation. If we were to go back and choose our T3V logo, for example, and let's hit the U key, bring up our keyframes for shatter threshold and delete them. Now, if we simply set our shatter threshold to a value higher than the absolute white, 50 is going to take the circle as well. So let's take it down from there so that we just have the T, the 3, and the V. And now that we know that we're at a value that's between the white and the gray, those pieces at the very beginning, as long as they're inside of our force sphere, should have permission to explode immediately, and they do. So as you can see, gradients can give you enormous control over exactly how things explode in shatter. We'll come back and show you exactly how to do a really cool organic effect using shatter gradients in just a bit. Now, another important area of shatter that involves using other layers as a source is creating custom shatter maps, which is a very important thing to know how to do from a design standpoint, but also involves a few tricks that I think are important to point out. So let's open up our custom shatter maps composition. And this time we're going to do something a little bit different, which is also going to point out one other feature in shatter I haven't talked about yet. We've got this beach balls layer here on screen, but instead of applying shatter to this layer, which would blow it up, I'm going to turn it off and I'm going to turn on our custom map layer, and I'm going to apply shatter to that. Effect, simulation, shatter. I'm going to switch things over to our rendered view so that we can see our original layer color here, but I'm also going to go under our textures, which I haven't talked about yet. Now, textures gives us quite a few controls here. It gives us separate controls for the front of the pieces, the side of the pieces, and the back of the pieces. We can control whether or not those pieces are a layer. In this case, we could choose beach balls for the front, and now our beach balls image is on the front of our shatter pieces, and as we hit the space bar, you'll see as those pieces turn around and we see their edges or even their backs, that the backs don't in fact have that same texture. So you can actually create effects that look as if the sides and the backs of pieces are mapped differently from the front, which can be pretty cool. But we could also say we wanted the front layer to not be any layer at all, but instead of layer, be color. And then the color would be assigned by the color chip up here. And you can do mixes of layer plus color plus opacity, etc. Try playing around with various mixtures of these and see what you come up with. We're going to choose the beach ball layer and layer as our front texture here. That's cool. We'll set another side texture in just a second. Let me jump back to Home, close down our texture section, and go back to our wireframe plus forces view so that we can see our shatter map. Now, we talked about a threshold operation a second ago, and the idea of a threshold operation is extremely important in how shatter sees the world. If Shatter was to look at this beach balls layer and use it to create a custom shatter map, it would accomplish that by doing a threshold operation on this layer. But instead of doing a simple black-white threshold operation, which would look like this, adjust threshold, everything above a certain luminance value would go white and everything below a certain luminance value would go left. While this could make an interesting shatter map, it's not going to result in too many pieces because you get these big giant areas that turn white and these other areas that turn black. So this isn't really suitable as a shatter map. You don't typically want to use just a plain black and white image. What Shatter does instead is it applies a separate threshold operation on the red channel, the green channel, and the blue channel, and then combines those three threshold operations into a single image that will be made up of 8 possible colors: black, white, cyan, magenta, yellow, red, green, and blue. We can force that exact view if we like by applying a filter that nobody uses for anything really because it's really fairly complicated. It's the channel arithmetic filter. Now arithmetic has all of these odd and confusing ways of mixing layers together that we're not going to much go into, but we are going to choose the slice command. And what slice allows us to do is show you what an RGB threshold operation looks like. If we set the red value to 127, the green value to 127, and the blue value to 127, we've just created an RGB threshold operation, and we're seeing the results of those 3 things mixed together, which can result in a possible 8 colors on screen. Shatter will now look at these exact values as you see here. Let's turn this off and go back to our custom map layer and turn it on and tell Shatter that for shape we want to do custom, and for a custom shatter layer we want to choose our beach balls. And look, there are our beach balls, and the beach balls are basically cut up into pieces that look exactly like the RGB threshold operation that we did back there. Now the fact that we created that RGB threshold has nothing to do with the fact that Shatter has actually created the same effect here, because we could go and modify that threshold operation and it wouldn't affect the shatter map at all, because once again, Shatter is looking at the pixels that come into a layer, which always look like this, and not at the layer as it's being affected by another effect inside the same composition. So this is a very good example of that. However, you could, in a pre-composition, create a custom threshold operation to make a shatter map look exactly the way you want it to look, as I'll show you in just a second. But at any rate, turn that layer back off again, and now we've got a custom map. We'll set it back to rendered mode. You can see our beach balls, when we hit the space bar, will blow into pieces that are based roughly on the shape of the object that you see on screen, which is a really cool thing and can create some really great effects. You can blow up your client's logo, you can blow up any graphical element that you have to work with. Now we're leaving a few of these weird pieces on screen, so I'm going to crank up our force to a radius of 1 and make sure that we've included everything on screen. Take a look at that again. Very cool. Now once again, these pieces are handled by Shatter's physics, so if we crank up the extrusion, we'll get a little bit different behavior. And because we can map separate textures on the front, the sides, and the back, sometimes I like to take a texture map that's animated. For example, the US flag movie that we have down here. Here we go. US flag. Great. And map that as a texture on the side of our shatter pieces. And the result of that will actually kind of look like a metallic reflection, which is a nice little trick. So we're getting a little difference in color as the layer tumbles out. It looks like we're actually getting a reflection map on there that looks pretty cool. But what you don't want to do, let's go back home again, go back up to Shatter. Instead of our front mode being the beach balls layer, let's set it to be the US flag. It'll automatically stretch it to the size of the layer. For our custom shatter map, let's pick the US flag. And if we switch over to wireframe plus forces, you'll see this is what our shatter map now looks like. Not exactly perhaps what you would predict, because you've got these obvious areas of blue and red and white. But when you do an RGB threshold operation on that, you don't necessarily get the predicted results. If I turn on our US flag movie here and apply effect arithmetic, set to slice, crank it up to 129 by 128 by something close to the middle there. And you'll see that this is what Shatter is seeing when it does an RGB threshold operation. The blue goes over to black, The stars stay kind of white. The white stripes kind of go from white to black, and the red also goes into black. So you get an interesting and odd sort of breakup pattern here. This is when it would be excellent to use something like Colorama to remap the stripes that you see here. We'll be talking more about Colorama in just a second. But a more important thing than seeing exactly how Shatter is seeing this layer is seeing what happens when you use an animated shatter map, which is basically that Shatter ignores the fact that the map is animated. As we move a few frames along, you'll see it doesn't take long at all before the texture map gets out of register with the pattern of the shatter. We've got what should be a stripe here that now has a bit of red and a bit of white on it. You'll see that the edges of our blue field now have pulled in some red and white stripes, and the stars don't line up with the holes anymore. And the reason is Shatter doesn't use animated maps for creating a custom shatter map. You don't want that, really, for a couple of reasons. One is that an animated map would likely produce a different number of particles on practically every single frame, which would be very bad. And the other thing is that if sizes of particles change and get bigger and smaller, it affects the physics of the simulation, and each piece would be calculated based on a different mass each frame, and that would just be impossible to keep track of. It would make the simulation A, very slow, and B, pretty ugly. It wouldn't look like anything in the real world. And so Shatter only looks at the first frame of an animated layer to determine a custom shatter map. Another thing you may be noticing is all of these tiny little pieces that fly out of the map. What you're seeing here is basically single stray leftover pixels that in the course of an RGB threshold operation you find along the edges of things. These are very, very hard to get rid of, I'm afraid, when you're working from a photographic image. If you really, really need a clean shatter map, there's a couple things you can do. One is work with a very high resolution map. I'll be showing you one of those in just a second. A higher resolution map will get sampled down to the proper size by Shatter and will create a much more accurate image. But the second thing is to actually go into Photoshop and search your map high and low for stray single pixels and manually change them. If you go in and paint out the single pixels that are responsible for creating all of these little stray sticks that you see flying around, you can actually get rid of them. And it doesn't take that long. It just takes a little bit of patience and a good eye. So let's go back to our shatter effect and go back down to our texture controls. Instead of our flag, let's choose our world map to be our foreground layer. We can keep the flag movie on the side if you like. It'll still look like a reflection map, which is cool. And now under our shape, for a custom map, we're going to choose our world map comp, which happens to, right now, if we double click on it, look exactly like our world map layer. But we're going to use this comp to show you how to fine-tune a custom shatter map so that things look a little bit better. If we just take a look at our shatter map as it was created by default, you'll see it has some problems. One is that it's extremely noisy. There's tons and tons of these little single pixels lying around. Another is that because of the threshold operation, the blue ocean isn't well separated in many cases from the green that we see in the land. You'll see that there's no separation at all between the ocean and North America. There's no separation at all between the ocean and this middle chunk of South America. And as a result, if we look at a rendered version of that and tap the space bar, we're not going to get a satisfactory explosion. You're going to see a lot of the mountains sort of blow out. But for the most part, the background is just going to stay one big slab with big chunks of green attached to it. And while it may be interesting, it's not really a satisfactory finished shatter animation as far as I'm concerned, where we would want to see these shapes of these continents blowing out of the ocean and the ocean maybe falling into pieces as well. So how do we fix that? What we need to do is we need to fine-tune the shatter map. To do that, again, as I've said a couple of times, we need to actually make sure that we are working in a pre-comp, that we are working on pixels in a pre-composition so that those pixels will come into this comp ready to work. So as we saw, I've chosen this world map comp, which is down at the bottom of our project window. I'm going to hold down the Option key on the Mac, the Alt key on Windows, and double-click on that comp. We'll open up our world map composition. Let's see what we can do about making this a better shatter map. We could, of course, go ahead and do our own custom RGB threshold by selecting the worldmap.psd and then choosing Effect Arithmetic, which we see at the top here, which I just showed you a second ago, and adjust the red value to 127. Hit the Tab key, type in 127. Hit the Tab key, type in 127. And yes, this is looking wrong because we haven't set this to slice, but set this over to slice, and that gives us the RGB threshold that Shatter wants to work with. And these black areas should show us exactly why we're seeing what we're seeing. So if we now kind of tweak these values around a bit, we should be able to bring in some of the shape of the continents, some of the green. We can threshold down a bit more, even the blue. I'm not sure about the blue. Let's keep the ocean one solid chunk if we can. But by tweaking these values, we should be able to at least get things to a point where the continents are separate from the ocean. And if we jump back into our custom shader map, we should see slightly more acceptable results. We're still seeing an awful lot of noise, but at least the continent shapes seem separate properly from the ocean. So that's a step in the right direction. So that's good. Let's go back home and go back into our world map comp. And instead of arithmetic, let me get rid of arithmetic. Let's instead apply effect, image control, colorama. Now we haven't seen this filter yet. And we're going to look at it in great detail pretty soon, but I'm going to twirl open the output cycle. I'm going to go down and turn off interpolate palette. By dragging these palette icons around, we can fine-tune the colors. More importantly, in our case, by adjusting the input phase to something like hue, we should be able to pretty quickly separate the various hues that make up this map and tune things around a bit more than they already are, give ourselves a more interesting shader map than what we had before. Also, in an effort to get rid of some of this noise, I'm going to accept this as okay for now. I'm going to apply a blur. Effect, blur and sharpen. Let's just pick a fast blur. Bring our window back up here, and we're going to grab our blur and we're going to drag it above our colorama. We're going to crank up the blurriness a little bit, and as we look at our layer, you'll see the noise level is going to drop tremendously. That's nice. It's very nice. So now our map should still have a little bit of noise up here at the top, but for the most part, things should have cleaned up tremendously. Let's go back to our custom shader maps composition, hit the space bar again. You'll see we're getting a lot closer to an ideal custom shader map. So this is very cool, but there's one last thing that bugs me about this, and that is, what if I wanted to just blow the continents out of the ocean, but I wanted to leave the ocean behind? I wanted to leave the ocean up here on screen. Well, it so happens that there is an easy way of doing that with the custom shader map. If I switch back over to my world map comp and we look at our map here, and I scroll down to colorama, I'm obviously making the ocean blue. What if instead of making the ocean blue, we made the ocean white? Just click right in the center to choose a white value, click OK, and now our ocean has gone completely white. Once that's happened, I can go back over to my other composition, hit the home key, and underneath my shape, pattern, custom shader map, I can choose this little checkbox that says white tiles fixed. And when I click on that checkbox, what that's going to do is it's going to tell Shader to explode everything on screen except for custom pieces that were made with white tiles. So now if we hit the space bar, you'll see that all the pieces related to the continents will now fly off the screen, but that the ocean, which was created from a big white tile, will stay fixed in place. And the results of this, I think, look pretty darned good. You've got the cool little texture on the side that gives it kind of a reflective look. You've got the obvious shapes of the continents cut out of the ocean there. We could certainly do some fine-tuning to get the Arctic and Antarctica to cut out a little more cleanly. Obviously, this is an artistic and tweaky process when you want to do things really, really precisely. But this should give you a pretty good idea about how to work with custom shader maps in After Effects. With one exception, something we haven't talked about at all yet, and that's creating custom shader maps with an alpha channel. For that, we're going to open up our next composition, Alpha, Shader, and Matrix. Now what I have in this composition is a layer that we're going to apply shader to. It's just a solid. Behind that, I have a deep core title, which happens to currently be black on black, but if I check its alpha channel, you can see the word deep core with white on black, so we're going to use that alpha information. Also, I have a deep blue sea background layer, which holds still and then pans over. Pretty simple, not much to it. Hold still, pans over, okay. And I have a texture map that I'm actually going to use for the sides and the back of my letters. Now in this case, we've already applied shader to this layer. If I hit F3, shader has been applied. In fact, if I turn it on, go back home and push the space bar, you'll see that it's actually already got a 3D effect applied to it, a camera move, animated, and it just so happens that the camera move matches the background that we've created. In fact, we'll turn the background on real quick. There's its visibility. Jump back home again, and you'll see we explode out, camera pans over, and we've got something looking cool already. Let's make it look even cooler. Twirl open my shatter effect and open up our window so we can see it more clearly. We'll open up our shape, controls, choose custom, and as a custom shatter map, we'll choose our deep core title. And notice, first of all, it takes a second longer to calculate it because it's a high-resolution image. But more importantly, it is only creating pieces where there is opacity. Because we have letters on a transparent background, we have now created letters on a transparent shatter background. And if I set our pop-up to rendered, you'll see basically shatter has created a 3D model of the words deep core. I can adjust their extrusion depth a little bit so that we can see just how deep the deep core is. That's pretty deep. There we go. I'm also going to twirl open my textures, and for the side layer, I'll choose the grip texture that we have down there. And for the back texture, I'll choose the grip texture. We won't see those now, but as soon as the letters start to spin and tumble, we'll notice that it's there. Now let me generate a quick RAM preview. We've got the viscosity set fairly high, so the letters will tumble very slowly, and the camera will move as the letters move, and the results look pretty great. The word deep core gets shattered out, and then the camera moves around, the background moves with it, and the results look like a real 3D move. Pretty fun. So as long as the detail of the extrusion doesn't need to be terribly high, you can actually use shatter as a rudimentary 3D modeler. Certainly works reasonably well for text. And if you want it to work even better, use a high-resolution map to create your text so that the edges of the letters don't get too jaggy. This is a great example of a good high-resolution map creating very usable letters for a title sequence. That's some of the cool stuff you can do with the custom layer maps, particularly with alpha channels. There's another common effect that comes up, something that people ask for a lot, and shatter is absolutely perfect for it, and that is, how do I blow away a layer on screen as if it's made of sand? Well, we have a few layers in here. We have a noisy ramp, which looks like this, ramp with lots of noise in it. Lock that again. We also have a backdrop. If I turn that off, you'll see, whoa, it's revealing our secret hidden title, Mummy's Brain. That's our mask layer. Behind the mask layer, we're going to reveal the actual written title of Never Awake the Mummy's Brain. That's one of our titles of our exciting, scary movies that's going to be coming up. And of course, we have these title elements that are on top of that. What we're going to do is we're going to use shatter to get rid of this mummy's mask layer. Going to blow it off screen like sand particles, and it's going to reveal the written version of itself as it blows off screen. Now we've already applied shatter to this layer, so let me hit the F3 key to bring up our shatter controls. And I'll pull those open here. And I'm going to pull together a couple of techniques that we've talked about and a couple that we haven't to make this look as realistic as possible. First of all, let me turn on shatter. Now familiar beach balls and brick scene comes up here. Let me turn off our background layer so we can set up a couple of things real quickly. I'll twirl open shatter. Instead of bricks, we want to use hexagons. And we'll set the repetitions on the hexagons up to something like 60 so that we get tons and tons of the things on screen. And we'll turn the extrusion depth down to 0. We don't need to think about all those polygons, and that'll make things work a lot more quickly now. So we have lots and lots of little hexagons on screen, and those are going to become our grains of sand. We need to go find our force 1 and make it large enough to blow all of the particles off screen that we want. So let's set that to 1. That'll make it more than big enough to blow up everything. And we also want to set the strength down. We want to set it down to something like 1. We just want to be able to disturb the particles a little bit and then let gravity take over. Now, under physics, we're going to adjust our gravity's direction because we want things to blow off the right-hand side of the screen. So we'll crank our direction over to the right, about 90 degrees. 88 will do fine. The amount of gravity will set up to about 4, I think, so that we speed off screen a little more quickly. And we're going to use a gradient layer. We're going to use that noisy ramp to control the order in which our particles are released. Now, if I hit the U key, we'll see we've already got a couple of shatter threshold keyframes set down here in the timeline. Let me hit the letter K, and that'll take us to our next keyframe. You'll see that they aren't actually animated yet. I need to change this second threshold value to 100, which I will. But now, over 1 second, this threshold should allow these particles to blow off screen. If you just take a look at them with that noisy gradient, you'll see we're already getting a fairly natural effect of things blowing off screen in a fairly random pattern, like so. But of course, we're just seeing the master particles. All we're interested in is the visible particles that are on screen. So let's switch it over from wireframe plus forces to rendered. Now if we take a look at the same thing, you'll see what we have is pieces breaking away from our mask layer and flying off screen in a fairly organic fashion. Now experiment with all different kinds of gradient maps for this sort of thing. Fractal noise works really well, not just gradients with noise. Fractal noise will allow patches to go at a time instead of this kind of random breakup, but this is going to work well for this particular animation. Let's just take a look at what we have up to there. That's looking pretty good. And now that we've done all of that tweaking, now that we are at a point where we know we don't want to do any further animation here, where we're happy with this animation, I'm going to do something a little bit different. I'm going to twirl down my shadow control here, and you'll see that we also have a drop shadow applied here. But there's a problem with using this from the get-go. The drop shadow will add a great deal to complete our effect here because the particles, as you can see, get fairly lost against the background unless we have a drop shadow turned on. Now they look much more clear and you can see them a lot better. The problem is, if we go back to frame 0, the drop shadow gives away the name of our movie that we're trying to reveal by blowing the sand off to begin with. We don't want the drop shadow on the layer when the layer isn't moving. We only want to apply the drop shadow when the pieces are actually flying off. So what do? Well, let's turn the drop shadow off. Let's select our mummy mask layer and duplicate it. So now we have a copy. On the backmost copy, making sure that we're in the effect control panel for that copy, we're just not going to use this drop shadow at all. We're going to keep it turned off. But we're also going to go into shatter and we're going to tell it to render only the layer. That means the undisturbed portion of the layer is all that's going to be rendered. And now we're going to go to our copy, the one that we just made, hit F3 to bring up its window, turn on the drop shadow, but tell it to only render the pieces. And what that means is this version of shatter is only going to render the pieces that fly off. The shatter on the layer below it will only render the pieces that are still stuck to the original layer, and the result is that only flying pieces will have a drop shadow. Pieces that are still sitting there clearly do not. And as we RAM preview this, you can see that we're most of the way towards a really great effect. Of course, you can tweak this, you can make the particles smaller, you could make the gradient map a little noisier if you wanted even greater randomness in the explosion. But pretty nice effect, pretty nice sand blowing stuff away kind of effect. That carries us through most of what we need to know about shatter. The last little project I want to show you is actually in its own composition. It's the composition called 5A Realistic Shatter. So let me close this down. I'm not going to save it. And I'm going to open up my project files and choose 5A-Realistic Shatter. Let's take a quick look at how I've created this effect. First of all, we took a large still digital photograph and we modified it a little bit in Photoshop. If we open up our Photoshop layers here, we can take a look at the shot of the building. If we zoom in, which is basically the total training building, we have modified the no parking sign, so now it says, warning, smoking is not permitted. Volatile chemicals present. If that isn't a tip-off for what's about to happen, I don't know what is. We've also painted out a window, as you see here. So if you look at the alpha channel, we've actually got opacity with this one transparent window here that we can see through. I extracted that window and used Photoshop's crop tool to scale it back into normal perspective so that it's basically a rectangular version of this perspective window that we see in there. And I also painted a fake foreground element, a couple of bushes that needed to go on their own layer so that they could mask things a little bit. And the results came in as a comp that I renamed Big Setup, which is what we're seeing right here. Now, as part of Big Setup, I've added a couple layers. I added, for example, this interior shot, which is basically just filmed in our offices of some people wandering in to camera in approximately the same angle that we would see through this window were it broken out. And if we turn off the visibility of these foreground layers, you can see that there's that interior shot right there. Here's the building right here. So you can see people wandering into the window and looking out. Can't see it very clearly, but if I zoom in a bit, you can. There we go. Hey, what's going on? Zoom back out again. You'll see our foreground element pops into place there. Looks like it lives there. You'd never know that it was fake. And lastly, I'll turn off our filter and turn on our window layer, and let's take a look at it a little bit closer. This window layer was actually pre-composed because I needed the shatter layer to be a little bit larger than the window because shatter tends to be clipped to the layer that you apply it to. We needed shatter to come outside of the confines of just the borders of this window so that we actually had pieces flying out. Next, I needed to match the perspective of our shatter effect to the scene that we're rendering into right here. And the way to do that is, let me pull up my effect controls, is with Shatter's corner pin camera. I turned on corner pins as a camera system, and with corner pins turned on, I was able to distort the layer so that we were duplicating the perspective of the scene by lining things up in our comp window with predictable perspective elements in a scene like this. It's not really hard. You've got a nice perspective to work with here with these windows. And when I turn our effects back on again for this layer, you'll see that the corner pin camera does a great job of actually mapping the perspective of the window layer perfectly into place. Now, another great reason that I did this in a pre-composition is that the pre-comp actually allows us to fine-tune precisely the positioning of this window. We can use corner pin cameras to get things more or less into place and match the perspective, but even then it can be a real bear to get the exact pixels into place. To do that, we actually want to go into the window composition that we created. Here it is. And I'm going to tear this out so that it's its own window. We can see it. And now you'll see that just by selecting the layer in the pre-comp and nudging it around, we can actually nudge the position of the window in place in the master composition. So by just fine-tune, clicking this window around, you can eventually precisely line it up exactly where it needs to be. You can make any scaling adjustments you need to here. You can make any positional adjustments you need to here until the window lines up precisely where it needs to be. And if I switch our view over to wireframe, you'll see that our wireframe nicely matches the perspective of the window, which is very important. And now with rendered view turned on, you can see that we've got a nice composition here. If I zoom in just a little bit more, pan over, and hit the space bar, you'll see that 1 second into the composition, the window blows out. We could do the shadow trick that we did before with the Mummy's Brain poster and actually apply shadows to just the pieces, but we've skipped that level of detail for this particular composition because I think it looks pretty good without it. Let's jump over to our Render Me version, which is merely a cropped-in version of the same effect. Generate a quick RAM preview and take a closer look at how our final effect looks. And if we take a look at it, whoa, pretty good. All sorts of things you could add. You could add a glow. You could add an Art Beats explosion if you wanted to. You could make all the windows go bright for just one frame just before the explosion happens. There's tons more you could do. But as far as compositing the shatter effect perspective-wise realistically into the scene, this works great. So shatter, it's not just for stylistic effects. You can use it for realistic special effects as well.